All right, we have a short lesson on solving with what we call the uniqueness property. So when we did this with exponents, remember it was something like this. If we had b to the m power equals b to the n power, we could say that m equals n. So numerically that was something like 2 to the x equals 2 to the 3. So x must equal 3. This is really similar with the logs. If I have the same base on the log, so either it's log base b or maybe it's both natural log, then I know that m equals n. So, and then conversely, if m does not equal n, then this is also not true. So numerically, if we took this same example, if I had log base 2 of x equals log base 2 of 3, then I know that x equals 3. That's how that would work out. So we're going to apply that to a problem here. Then I'm going to give you an opportunity to work on another problem before you see me go through it. So I can see that I don't have a base present here, so that means it's log base 10 on both sides. So that means if I have a situation where it's just log on one side, log on the other, same base, then I can just say that 5x plus 2 equals 2. And now I just solve it like any other algebra problem. I subtract 2 from both sides. I get 5x equals 0. Divide by 5 both sides, so x equals 0. So anytime that you can solve using the uniqueness property, it's a much simpler way than some of the other ways we solve, then you should. So here's another example of what that could look like. Here you see that I don't have it all like just simple log base 3 equals another log base 3, but I could combine them because I know that this means division. So give yourself a second, really try this on your own, and then so pause your video, and then when you come back, I'll solve it with you and you can check your work. All right, I'm assuming you had some time to pause. So properties of logs say subtraction is the same as division. So my first step might be to write this. X plus 6 divided by x equals log base 3 of 5. And now I have it set up where I could use the uniqueness property. So log base 3, that's the same, so they can basically disappear, leaving me with just x plus 6 over x equals 5. Then to get the x out of the denominator, I'm going to want to multiply both sides by x. So here they cancel out. That leaves me with x plus 6 equals 5x. And now I just want to get x's on one side and numbers on the other. So I subtract x from this side. I get 6 equals 4x. Divide by both sides by 4. So I can see if I reduce that fraction that x equals 3/2. Again, still even with having to do some more difficult algebra, this is a much simpler technique than what we were doing even just in the previous short lesson. Anyway, if you have any questions, remember we'll talk about it either next Zoom, or you can email me this week with any questions on any of the work we've been given. We can set up office hours as well. Also, there will be a Google form just kind of going over some of these questions, similar types that you solved, and that'll help give you some feedback and give me some feedback on that. All right, thanks.